Now it says, for each of the following, compute the desired derivative. So what we're going to do here is we're going to say, well, we want g prime of x. And that equals 3, coming from right there, times e to the 2x, but we want the derivative of that, minus 2 times the derivative of x to the third plus the derivative of 9. So we can see over here that e to the at, which is what we have, a equals 2, is equal to 2e to the 2t. Or we have x's, it would be 2e to the 2x. That's the derivative of e to the 2x. Minus 2 times, and notice that because I took the derivative, I got rid of my prime. Now I'm on minus 2, and I need to take the derivative of x to the third power. That's the power rule. T to the n equals n, t right here. T to the n equals nt to the n minus 1. That means that this equals 3x to the 3 minus 1, which is 2, plus the derivative of 9. Well, 9 is a constant. The derivative of 9 is 0. So plus 0. This equals 6e to the 2x minus 6x squared. And I could simplify or factor this and say this is e to the 2x minus x squared. And that is my derivative. Now it says compute g prime of 2. Well, g prime of 2, I replace my x with 2, which gives me 6e to the 2 times 2 is 4, minus 6 times 2 squared, which is equal to 6e to the 4th minus 24, or we could also say 6 times e to the 4th minus 4. And that would be my final answer. Let's go on to the next one. Here I have h of t equals 3t squared plus sine 3t plus 3e squared. Compute h prime. H prime of t is equal to 3 times the derivative of t squared plus the sine of 3t. We want the derivative of that, plus 3e squared, and I want the derivative of that. For the first one, I have 3, and I'm going to use the power rule, times 2t, plus, now I'm on the sine. The sine of 3t is this, where omega is equal to 3. So the derivative of the sine is the cosine, which gives me 3 times the cosine of 3t. Last, I have 3e squared. 3 is a constant, e is a constant. E is always going to be the same. So that means that e squared is also a constant. If I square 3, I still have a constant. If I square e, I still have a constant. This entire term here is a constant, and the derivative of a constant is 0. My final answer here would be 6t plus 3 cosine of 3t. And of course, I can factor out a 3, which gives me 2t plus cosine of 3t. And again, that's my final answer. That's the derivative. Number C. if f of t equals minus t plus 2 plus cosine of 3t, we want to first compute the derivative and then let x equal 0, which gives me f prime of t equals, the derivative of t is going to be 1. We have minus t prime plus 2 prime plus cosine of 3t prime. This is really the same as t to the 1 power. If I use my power rule, it says bring that exponent down. I will get 1t to the power of 1 minus 1, which is 0. So I have 1t to the 0, but t to the 0 is 1. So this is really just minus 1. Plus derivative of a constant, 0. Plus, now we're looking here at cosine of 3t, where omega is equal to 3. And notice this one is negative sign. So we get negative sine of 3t. But remember, it's times that omega, so it's minus 3. And that is the derivative. Let's say we have minus 1 minus 3 sine of 3t, where t equals 0. This is f prime of t. F prime of 0 is equal to negative 1 minus 3 times the sine of 3 times 0, which is 0. The sine of 0 is 0. This answer is negative 1. F prime of 0 is equal to negative 1. I want dy dx. Notice all the different notations. This is equal to 3 times the derivative of e to the minus x, plus 4 divided by, and I'm going to change that denominator. I want to make sure that you have this rule down. The nth root of x to the m is really the same as, I can put that m on the outside. All of these are the same as x to the m over n. I want to change that x into this form so that I can use my power rule. This becomes x to the 1/3 power. And then I can say plus e to the 3rd power. And we're going to take the derivative of both of these parts. Now we have 3. The derivative of e to the minus x, well, minus x, a is equal to negative 1. So it would be times negative e to the minus x. Also, here, I'm going to leave this in the derivative form still because I'm going to do a little algebra. I'm going to bring that x to the numerator and make it 4x to the minus 1/3. And then e is a constant to the 3rd power is still a constant. It doesn't really matter. E is a value. If you put it into your calculator, you'll find a value. If you put it to the 3rd power, you'll get the same answer every time because it's a constant. The derivative of a constant is 0. This one's still prime because I didn't take the derivative yet. This becomes minus 3e to the minus x plus 4 times, we're going to use our power rule, which is minus 1/3 x to the minus 1/3 minus 1, which equals minus 3e to the minus x. I'm going to take that negative out, minus 4/3 x to the minus 4/3 power. First, I'm going to say this is minus 4/3x to the 4/3, because that's really what a negative exponent does. So this becomes minus 3e to the minus x minus 4/3. And now I have more than one x. I have x and a third. X times x 1/3, which equals minus 3e to the minus x minus 4/3x times the cube root of x. Now let me just say, a sufficient solution would be this. This. All these are equal. I don't like that one, but I would say this is fine as well. So any of those three answers would work. Find equations of the tangent line to the curve y equals 4x squared minus x cubed at the point 1, 3. It wants the equation of a line. In calculus, most of the time, the equation that we're going to use, because we're usually given a point, is going to be point slope, which is y minus y1 equals m times x minus x1. Well, we know our point. We have y minus y1 is 3 equals m times x minus 1. However, I don't know what m is. How do I find m? M is the derivative. The derivative is the slope of the line tangent to a curve at a point. That's what it is. That's all I have to do. If my original function is y equals 4x squared minus x to the third power, my derivative, which I can write as dy dx, I can write as y prime, is going to equal 4 times 2x, or 8x, minus 3x squared. All I did was use the power rule. Now what I'm going to do is plug in my point. My point is x equals 1, which means 8 times 1 minus 3 times 1 squared, which equals 8 minus 3, which equals 5. Now I know the slope. This is the slope of the tangent line. I'm going to plug that in to my function, and I get y minus 3 equals 5 times x minus 1. And that is my solution to number 2.